Okay, guys, I'm going to start you off with some announcements again today. I noticed that yesterday's announcements was really helpful for us to, one, just know where we're at with all of our assignments, and two, some of us just needed a reminder on our points. So let's start off with some data. Okay, we're actually off to a much better start than we were last Monday. Out of the 77 scholars that we have in our classroom, 58 of you had your assignment complete by this morning. Sweet. Two high fives for all of you. That still puts us, though, at about 21 scholars who did not complete their work. That's pretty much an entire class. So let's work really hard today to make sure that as many of us can finish today's assignment as possible. All right, next announcement is if you watched yesterday's video, you got every single guided practice question correct. And because of that, you are going to receive 2 additional points for showing your core values. Those 2 core values that you show were respect and self-determination. Respect because, one, you understand that you should watch the entire video in order to successfully learn and understand what's happening with all of the questions. And self-determination because you took responsibility for watching the entire video. So these group of scholars right here are going to receive 2 additional points today because every guided practice question is correct. Guys, I give you the answers in the videos. It is so silly that so many of you still are getting those questions wrong. I give you the answers. Let's just do the work together. So, Andrew, Victoria, Josette, Victor, Kimber, Araceli, Nayeli, Tristan, Jeremiah, Giselle, Nevaeh, Nala, Adrian, Justin, Nicole, Lowana, Alex, and Josue. All of you scholars are going to receive 2 additional virtual Vista points in your bank account. Sweet job, guys. Good luck on today's guided practice. Watch the video, all of it. And also don't forget to do your ELA and your Lexia minutes for today. Happy Taco Tuesday! Okay, let's start off today with a story problem. In today's story problem, it's about a young girl named Gina who is making a cake. You know, when you're making cakes or when you're baking in general, you have to measure all of the different ingredients. Why do you think you need to measure all the ingredients, especially when you're baking? In order to get a recipe correct, you have to have all of the correct ingredients and, more specifically, the correct amount so that it tastes good. If you have too much sugar or not enough flour, then it may not even taste at all what you want and it might be really gross. So Gina's baking a cake, and Gina's cake, of course, has sugar in it. And her specific cake needs 7/8 of a cup of sugar. She only has 5/8 of a cup. So how many more cups of sugar does Gina need so that she could make her cake? Does Gina have enough sugar to bake her cake? No. 5/8 is less than 7/8. She doesn't have enough sugar. So she needs to figure out how she's going to get more sugar. Take the 3 minutes to figure out how much more sugar Gina needs in order to be able to bake her cake. And in today's story, we are measuring the sugar in cups. That's right, cups. And not just an ordinary cup. While you cook, you actually have a specific utensil called a measuring cup. And it's not a cup that you actually drink out of. It's really something that you measure all the different ingredients in. In those 3 minutes, take the time to double check your work, and if you have enough time, show a strategy a different way. Think about how you can draw a picture of the cup of sugar that Gina already has. go ahead and go to work. Now that you've taken 3 minutes to figure out how much more sugar Gina is going to need to get so that she can successfully bake her cake recipe, I was actually able to solve it 3 different ways. My first being a picture, and then I did number sentences here at the bottom. But first, I went ahead and annotated important information from the story. The first thing that I annotated is how much the entire cake recipe was. Well, her entire cake recipe called for 7/8 of a cup of sugar. 7/8 of a cup of sugar. And currently, Gina only has 5/8 of a cup. And the question was asking how much more she was going to need. We had already established that 5/8 wasn't enough. So when I drew my picture, I knew I was going to need to show 8 equal pieces because 8 here is my denominator, which means eighths, which means, that's right, eighths. And because I have graph paper, it was really easy for me to just use all the lines. So I used a big, tall rectangle. And in my brain, it kind of actually looks a little bit like a cup. So it looks pretty realistic. So I then drew one whole rectangle and I split the rectangle into 8 equal pieces. 1, 2, 3, 4, 5, 6, 7, and 8. And I thought it would be best to show how much sugar Gina needs altogether. So in the black, you could see 7/8 was colored in. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. Well, 7/8 wasn't the entire cup of sugar, which was okay. Again, that was the information from the story. So I then drew the amount of sugar that Gina currently has, and I did that in blue. And as you can tell, I kind of just went over it. So it overlaps. 1/8, 2/8, 3/8, 4/8, 5/8. So this is only the amount that Gina actually has right now. She needs 7/8. So when I was thinking how much more she needed, I just count each of these pieces right here. Each of these pieces equals 1/8. So 1/8, 2/8. Looks like in my picture, she needs 2/8 more of a cup of sugar to have what she needs for her recipe. When I used a number sentence to solve how much more sugar she was also going to need, it pretty much matches my picture because I started with 5/8, then I counted up, which is adding to 7/8. So 6/8, 7/8. That's 2 more 8s. Since I know that subtraction is the opposite of addition, who remembers that word that we learned a couple weeks ago that means the opposite? That's right, it's the inverse. So subtraction is the inverse of addition. So I could start with the big number. 7/8 minus 5/8 is 2/8. That's like doing 7 minus 5. 1 left with 2. So it looks like Gina needs 2/8 cup of sugar for her recipe. Let's go ahead and mark 2/8 as the answer for the story problem. Just do you guys like my giant new cursor? Isn't it neat? Oh, by the way, I can change it to different ones. Like this one. Oh, that was really cool. That's a paper airplane. Okay, maybe I'll start to do the different ones all the time. All right, go ahead and organize your scratch piece of paper for question number 2. Then go ahead and read that question to yourself. Okay, question number 2 says, which of the following fraction models represent one whole? Select 2 that apply. So we're looking for 2 things. What are those 2 things that we're looking for? Well, the first thing is that we're looking for a picture that represents one whole. And the second thing, a little tricky of a question, but the second thing is that we're actually looking for 2 answers. We're looking for, that's right, 2 answers. So on our scrap piece of paper, we're going to look for 2 things. A picture, and it says that represents. That's basically equals. So picture that equals, I'm making mine in capital letters, equals one whole. And we need to find 2 answers. All right. So since we need to find 2 answers, we're going to evaluate each choice. Evaluate each choice means that we're just going to go through them one by one. Again, that word is evaluate. We're going to, that's right, evaluate. Okay. Paper airplane. The first one, well, actually, when I look at all the answer choices, scholars, they're all circles. So that's really nice. And then the next thing I notice, the circles are all circles are all broken down into the same equal size pieces. Quickly take a look and figure out how many equal size pieces all of the individual circles are divided into. Well, they're all divided up into eighths. When we go ahead and count them, and actually I use my little airplane. Oh, turns into a finger. There we go. 1, 2, 3, 4, 7, 8. So those are equal size pieces. There are 8 of them. Looks like they're pretty much all the same. So when we go through each picture, all we need to do is just count the ones that are shaded. Those are the ones that are shaded are going to be the ones that represent that model. So in the first one, it's 1, 2, 3. And it looks like that's the same for all of them. So for letter A, we're going to write 3/8 plus 3/8 plus 3/8. Okay, so when I go back and I look at this model, one of the things that I have to remind myself all the time is that when I'm combining fractions, the size of those pieces don't change. So remember, fractions are pieces of a whole, just like when we look at this picture. So in the first picture, in the circle, if I were to take each of these 3/8 and I were to combine them into the second circle, would the size of those pieces change? No, there would just simply be more of them. And if there's more of them, all I'm needing to then do is count the number of equal size pieces we have. So what that basically means is that when we're adding 3/8 plus 3/8 plus 3/8, we're only adding the top numbers because the numerators are the pieces in one whole. So like if we go back and we think about that picture, there are 3 equal size eighths in that picture. So when we combine them, we basically get 3, 6, 9, 9/8. And we're not adding these bottom numbers right here because the size of the pieces are eighths. So again, when we combine them, they're not going to turn into 8, 16, 24. You can imagine that 24ths would be really small pieces. It's not the same as what's in the picture. Okay, for letter B, go ahead and look at the model, and just like the first one, write the fraction that the model represents and the number sentence and see if you can already find the sum. Okay, when we look at choice letter B, the first one has 1, 2, 3, 4 eighths. So this picture represents 4 eighths. And the second one, it's 1, 2, 3, 3/8. And then the third one is also 3/8. So your number sentence that matches this model is 4/8 plus 3/8, 3/8. And when I combine them, that would make 10/8. All right, now go ahead and do the same for letter C. Look at the model, find the fractional value, and then go ahead and evaluate the number sentence. Okay, looking at model C now, the first one is 2/8. Looks like the second one is the same, which is also 2/8. And the third one is 4/8. So your number sentence for that one should be 2/8 plus 2/8 plus 4/8. And altogether that equals 8/8. Okay, we've evaluated 3 choices so far. Now let's go back to remind ourselves what the question is asking. We're looking for a picture that equals one whole. Well, when we know about wholes, we know that we should have all of their pieces. Well, in every single picture, there are 8 equal size pieces. So we're looking for the one that specifically equals one whole. Just to give you a hint, we're actually not going to go more than one whole. It has to be exactly one whole. So is 9/8 equal to 1 whole? No, it's actually more than 1 whole. So 9/8 would not be a picture that represents 1 whole. Let's look at letter B. That one was 10/8. Well, if 9/8 does not equal 1 whole, 1 more 8, which makes 10/8, would also not be 1 whole. And for letter C, we had 8/8. That is indeed equal to 1 whole. 8/8 would be 8 equal sized pieces of the 8 pieces in the entire whole. So letter C would be one of our answer choices. Go ahead, choose letter C. Well, the question is asking us to find 2 answers that apply. So I'm going to go ahead and give you about 30 seconds to evaluate D and E. Which one of those choices has a model that represents 1 whole? Okay, so when we're looking at D and E, there we go. Awesome, cool. Okay, so in the first picture for answer choice D, it was 2/8 plus 6/8 plus 2/8, which makes 10/8. And going back to answer choice B, that was also 10/8. So that one does not equal 1 whole. 6/8 plus 1/8 plus 1/8 was the fractions for the answer choice E. And that all together makes 8/8. 6/8 plus 1/8 is 7/8. One more 8 is 8/8. So answer E is also our second choice. So go ahead and make your selection. Yeah. Okay. Question number 3 says, which of these expressions are equivalent to 1 whole? Select 2 that apply. Go ahead and make some annotations on your scratch piece of paper for question number 3. Okay, so 2 important details from question number 3 is to find a number sentence that's equivalent to 1 whole, and you're looking for 2 answers. So this is basically exactly what we did for question number 2. The one difference that I'm sure you already noticed is we actually don't have pictures now, we have number sentences. So one thing that's I think is really, really important for these is to do the number sentences, but to also draw a picture, especially if you're unsure about some of these. And as I'm looking through them, especially these subtraction ones, it's going to be really important that we draw pictures for those. Okay, so letter A is 1/2 plus 1/2. Well, when we combine 1/2 and 1/2, what does that make? That's right, 2/2. That's something that's really easy for all of us. We know that one. Well, is 2/2 equal to 1 whole? For sure. Okay, letter B says 1/3 plus 1/3. All right, now I'm going to go back to my scratch piece of paper. First one was pretty easy. So when we combine 1/3 plus 1/3, if we go back and think about what we know about 1/2 and 1/2, that makes 2. Well, 1/3 plus 1/3 makes 2/3. Well, if we draw a really quick picture to represent thirds, so I have a rectangle showing 3 equal pieces. Here's my 1/3, and here is my other third. Well, when I combine them, does that make 1 whole? No. So this is not going to be one of our answer choices. Okay, letter C. So this one definitely we're going to model. So 3/4 minus 1/4. Well, we know that when we're adding fractions, we don't combine the denominators. So would you think that rule is still true when we're subtracting? Does the size of the fraction change when we take pieces away? No. If I have 3/4, 3 of 4 pieces, and I took away 1/4, we're going to have 2/4. And going back to what we did with 1/3 and 1/3, if we draw a picture of fourths, so here's my rectangle, my 4 equal sized pieces. And here are 1, 2, 3 of them. Well, if I'm showing one of the fourths going away, like that, I can just cross it out. I'm left with 1/4 and 2/4. Now again, thinking about the question, is that equivalent to 1 whole? No. So just like question number 2, I'm going to give you 30 seconds to do D and E. I'm also going to do the work on my scratch piece of paper as well. So about 30 seconds, we'll come back together. Okay. Answer choices D and E have addition and subtraction, and we actually both just did an addition and subtraction examples together. So you can use what you know about adding and subtracting, or you can use a model. So I use both to help me understand what the question's asking and to make sure I was correct. Just gotta adjust. Sweet. Cool. There we go. Okay. So D is 4/5 plus 1/5. As you can see, I drew lines to represent the 1, 2, 3, 4, and then the 1/5. And then you might have noticed that like I drew them in different directions to help me understand differences between them. And when I combined them, I got 5/5. When I combined them, I got 5/5, which equals 1 whole. And the last one, which is 5/6 minus 1/6, you take away a 6 from 5, you get 4/6. So here's my picture right here of 6, 6. 1, 2, 3, 4, and 5. Take away 1, and I'm left with 1, 2, 3, 4, 6. Now, does that look like 1 whole? Nope. Okay, so for number 3, we have D and we have A. And those are our two answers. All right, friends, click next. And then go ahead and get started on your independent practice. Be sure to draw all of those models that we practiced together in our guided practice. It's like the funnest part about fractions. Don't forget to also do your ELA assignment and your Lexia minutes. And for those of you that need some extra help today, go ahead and visit office hours at 2:30.